In this session, we will learn how to record specification of different solar panels and compare specifications to select a panel. At the end of this session, you will be able to know the specifications of solar panels, study the specification chart for solar panel and compare the specifications of different rated solar panels.
Now let us learn about the typical specifications of a solar panel. The typical specifications include test certificate, manufacturer's test certificate, and quality standard. Backside of the solar panel. In a designer approved single line diagram, these points are already considered and made available in SLD and part list. The technician can verify as far as possible the panels issued for installation or drawn from store shall have the information correct. Let us see the other features to be verified in the solar panel. ASTM is the standard spectrum or the type of light that shines on a solar panel. Production tolerance. Manufacturers often assign an allowable tolerance of plus or minus 5% to the module's rating. Hence, a 100 watt solar can be either 95 or 105 watts. Temperature. Higher cell temperature than the 25 degrees Celsius will decrease efficiency. Roof-mounted arrays will show temperatures in the 50 degrees to 75 degrees Celsius range, which is 2 to 3 times the STC rating. Dirt and dust. These block sunlight reaching to cells. Eventually, panels get dirty until the next rainfall or hose spray. This can account for about a 2% on average loss. Wiring losses. DC wiring accounts for power losses due to the resistance of the wiring system. We usually design for a 2% wire loss. Inverter losses. On average, over a day, this is about 90%. Success in the solar industry starts with testing and certification. To thrive in the solar energy sector, manufacturers and retailers need to ensure that their products meet established quality and performance standards. This means demonstrating that their PV modules are robust and able to consistently deliver the guaranteed rated power reliably even under more severe climatic conditions. They must also be safe and durable, ensuring the system's high yield over the long term and still need to be commercially viable. Industries have developed testing services that address market needs and enable users to meet their goals. At ISO 17025 accredited laboratories around the globe, the manufacturers test and certify PV modules according to national and international standards, including IEC 61215 and IEC 61730. Besides this, they offer testing under special as well as more severe conditions, performance characterization, and energy yield testing, just to name a few. International standards such as EN, IEC, ANSI keep abreast of changes and harmonization that affect market access for PV modules. Few certification services consist of the following process steps. Laboratory tests on samples for a module family or type, recurring factory inspection, certificate and TUV Greenland test mark, certificate of conformity COC or declarations for individual markets, and bankability reports. Quality assurance measures for PV modules include PID, potential induced degradation, electroluminescence and IR imaging, pre or post shipment inspections, aging of micro cracks, and LID test, light induced degradation. Stress tests include fire tests, corrosion tests, outdoor long-term tests in different climate zones, transport and environmental simulation on PV module shipping units, sand abrasion tests, and snow load testing. Added value services are PV plus benchmark, qualification plus certification, and energy yield testing under actual climate conditions in relevant target markets. BIPV. Qualification of building integrated PV include risk analysis, roof integration, facade integrated systems, hail testing, and snow load testing. Measurement of area of the cells and compare with the module area in data sheet. Every solar panel is made up of individual solar photovoltaic PV cells. PV cells come in a standard size of 156 mm by 156 mm. For example, if the area of one PV cell is 243.36 cm square, area of 60 PV cells is equal to 14,601.6 cm square. Area of a solar PV panel of 60 cells is equal to 16,335 cm square. The average size of solar panels used in a rooftop solar installation is approximately 165 cm times 99 cm. The length can go up to 182.88 cm. Most solar panels for rooftop solar installations are made up of 60 solar cells, while the standard for commercial solar installations is 72 cells and can go up to 98 cells or more. The number of solar cells on one panel is directly related to its length. 72 cell commercial solar panels are approximately 33 cm longer than 60 cell residential panels. If you install a 6 kW system with 20 average sized panels, your system will likely measure approximately 8.23 meter wide by 3.96 meter long is equal to 32.59 meter square. Testing using multimeter is easier. Test the solar panel for voltage across the output terminals. For this, first keep the solar panel in sunlight. Set your multimeter to DC volts setting. Touch the positive lead to the panel's positive wire and negative lead to the negative wire of the solar panel. If meter reads selected range is low, rotate the dial to increase the range. Note the voltage displayed and compare it with VOC rating given on the back of the panel in the label. It should be close to VOC. If it reads, so then the given solar panel is good. If it is not, then there is a problem with the given panel. In such a case, go back and check the connections of solar cells strings for any break or any crack in the solar cells. If you find anything like that, we can't repair ourselves. It should be sent to manufacturer for repair or replacement. Series connection. Solar PV panels connected in series are called string. Strings connected in parallel make an array. For a series connection, connect positive terminal of one panel to the negative terminal of other panel and so on. Then positive terminal of first panel is the positive terminal of the series path and negative terminal of last panel is negative terminal of the series path. The voltage of series connected panels is addition of individual panel voltage. The current path is single and hence series connections current is equal to current of a single panel. Conditions are all panels in series path must be of same ratings and specifications. No mixing of ratings is allowed. Here is the calculation method for series connection. For a parallel connection, connect positive terminal of all panels together and connect all negative terminals together. Terminals taken out from any one of the panel gives positive and negative terminals of the combination. Here is the calculation method for parallel connection. Let us now test your understanding on the concepts learned. You need 5 watts, 10 watts, 40 watts and 250 watts polycrystalline modules to perform this task. The task is to compare the specifications of different solar panels. Study the specification chart provided on each panel and fill up the table. Compare and comment on their suitability for your use.
We have reached the end of this session on record specification of different solar panels and compare specifications to select a panel. By now, you should be able to know the specifications of solar panels, study the specification chart for solar panel and compare the specifications of different rated solar panels.